So your book calls this other category of binary compounds type 3 binary compounds. And I try to use the same terms that your book does, but I really don't like this one. I prefer the term binary covalent compounds. I think it's a little more descriptive. The numbers 1 and 2 kind of make sense with those ionic ones because type 1, those ions only form one ion, those metals. Type 2, they form 2 or more. But this type 3 binary, this doesn't make any sense to me. So I'm going to call them binary covalent compounds. These are between two nonmetals. So we look at the formula. The first one is not a metal. We're not going to use the same rules. And this is where we get to use prefixes. So we're going to name the first element just using its full element name. The second element, we're going to name it like it was an anion. We're going to change the ending of its name to "ide," even though it isn't an ion. And then we're going to use prefixes to tell how many atoms of each are present. So the prefix mono means one, but we never use that on the first element. If there's one of the first element, we leave the mono off. And it kind of falls into that pattern of ignoring the number 1. It's a good thing that the number 1 can't sue chemists because he would have a pretty good case. These are the prefixes. And you need to know these. Mono means 1, di means 2, tri means 3. Those are probably fairly familiar. A triangle has 3 sides. Tetra is a weird one. That might be new to you. Tetra means 4. Think of Tetris. You ever played Tetris? The little blocks in Tetris have 4 sides, and each of those shapes that fall has 4 blocks in it. Maybe you didn't notice that. Penta is 5. Pentagon has 5 sides. A hexagon has 6 sides. Hepta is weird also. Hepta means 7. Octa means 8, octagon. So we need to know what those refer to. There are more, but we won't use them. So let's do some examples. Writing names for these guys. So we look at the compound and we see we've got C and O, 2 elements. We look at the first element and find it on the periodic table. Is it a metal? No. It's a nonmetal. We've got 2 nonmetals. So then we get to use the prefixes. Students like the prefixes, and they want to use them everywhere. You can only use them with these kind. So we're going to use prefixes to tell how many. Now there's only 1 carbon, so we're not going to use mono on that. We're just going to call that carbon. And then there are 2 oxygens. The prefix for 2 is di, so this is carbon di, and we take oxygen and change it to oxide. So this is carbon dioxide. Here's SF6. Again, we identify that there are 2 elements. The first element, we find it on the periodic table. It's not a metal, so we can use prefixes. S stands for sulfur. There's 1 sulfur, so we don't say monosulfur. We just say sulfur. And then fluorine becomes fluoride. And what's the prefix for 6? Hexa. So hexa fluoride. Okay, and there is no flower in fluoride. Okay, this is the common misspelling. You put the O first. It looks like the word flower. No, it's fluoride, F-L-U-O. N2O4. 2 elements. Find the first one on the periodic table. Is it a metal? No. We can use prefixes. So N stands for nitrogen. How many nitrogen atoms are in this compound? 2. So we put the prefix di. Dinitrogen. If mono is on the first one, we leave it off, but we use the other ones. So dinitrogen And which prefix means 4? Tetra. Tetra oxide. Dinitrogen tetraoxide. So these compounds, like the ionic ones, have 2 names. A first name and a last name. A name for the first element, a name for the second element. What's the name of this guy? SeO2. 2 elements, right? Find selenium on the periodic table. Is it a metal? It's right here. No, it's not a metal. It's actually a semi-metal. I really need to bring in some tape and make a line on this. No, actually, it's not even a semi-metal. It's so disorienting without the line there. It's a non-metal. So it's a non-metal, then we can just automatically rule out C and D, because Roman numerals are only used with metals, and there's no metal here. So selenium oxide or selenium dioxide? Dioxide. We need to tell how many. The reason we use the prefixes is because otherwise, if I gave you the name selenium oxide, how would you know how many oxygens there are? There's no charges to tell you, and so we have to use the prefixes and spell it out, literally. There's a flow chart, which may or may not be helpful to you. Things to ask yourself as you name things. Is it a binary compound, meaning 2 elements? Yes. Okay. Is there a metal present? If no, then you come over here and you use the prefixes. If there is a metal, does it form more than 1 cation? If yes, then you have to figure out what the charge is and use a Roman numeral. If it does not, then you just use the element name and you go on. So that can help you figure this out.